Hello, everyone. We have previously studied the relevant knowledge and principles of circuits. In this lesson, we will learn how to draw a circuit diagram for the microcontroller main control module using multisim simulation software. For components not available in the library, we will substitute with those that have similar parameters. We will also measure the operational parameters of the circuit to verify whether it can be used normally. Next, we will learn to use the software to simulate the microcontroller module. The goal of this lesson is to learn how to verify the function of the microcontroller module through simulation. The microcontroller simulation module designed based on the schematic diagram is to be simulated this time. We need to verify that when switch S1 is closed, multimeter 1 reads 5 volts, when S1 is open, multimeter 1 reads 3.5 volts. Next, I will demonstrate how to draw the simulation circuit. Step 1. Create a simulation file and save it. Open Multisim 14.0. In the menu bar, left-click on File, select Design, and then click on New File to create a blank design. To better save the relevant operating data in the design, first establish a folder and name it, then name the design file as Simulation Experiment of Microcontroller Module and save it to the folder. Step 2. Operate the circuit design within the design file. First, identify the corresponding simulation components according to the circuit schematic diagram. Find an 8051 microcontroller in the component library and set up the workspace path and name. Next, locate VCC and GND in the component library. Subsequently, select the corresponding capacitors and crystal oscillator from the component library. Then, summon one resistor and one switch. In the instrument column, choose 2 multimeters and 1 oscilloscope, and select Grounds, GND. Now we have found all the simulation components based on the schematic diagram of the circuit. The second process is to connect the corresponding simulation components according to the schematic diagram of the circuit. First, organize the components in their respective positions. VCC is connected to the positive terminal of C1, and the current flows from the negative terminal of C1 through R1 to the ground. S1 connects across both terminals of C1. The negative terminal of multimeter XMM1 is connected to the ground, and its positive terminal is connected to R1, as shown in the video. C2 is connected to one end of the crystal oscillator and to pin 18, XTAL2, of U1, while C3 is connected to the other end of the crystal oscillator and to pin 19, XTAL1, of U1. Pin 20, G and D, of U1 is connected to the ground. C2 and C3 are also connected to the ground, as shown in the video. Pin 9, RST, of U1 is connected to the positive terminal of oscilloscope XSC1, which in turn is connected to the negative terminal of C1 before S1, as shown in the video. The negative terminal of oscilloscope XSC1 is connected to the ground. VCC is connected to pin 40 of U1. The negative terminal of multimeter XMM2 is connected to the ground, and its positive terminal is connected to where C2 and the crystal oscillator meet. With this, the task of connecting the corresponding simulation components according to the circuit schematic diagram is completed. Next, we will proceed with the simulation test. Bring up the page displaying the multimeter data. Both multimeters measure voltage, but XMM1 measures DC while XMM2 measures AC. Note that we bring up the page displaying the oscilloscope data. Click the simulation button with the mouse to start the simulation. As the simulation begins, we can adjust the scale of the oscilloscope to observe the waveform changes. From the simulation waveform, it is evident that when S1 is closed, multimeter 1 reads 5 volts. When S1 is open, multimeter 1 reads 3.5 volts. The simulation achieves the expected results and is successful. Through this lesson, we have preliminarily learned how to verify the function of the microcontroller module through simulation. You are encouraged to practice independently after class. That's the end of this lesson. Thank you for watching.